Our project is called Grasping Concept Spaces. In short, we essentially explore how we can use VR to interact with high dimensional data in what is hopefully a more intuitive way. We know that there are different types of data, such as images, audio, text. These can be put through a vector embedding model, and we get vector embeddings. The reasons why we might want to do this is that it basically captures semantic meaning of data in numbers. We can now feed this data into sort of machine learning models, which they understand. It's a challenge. If our input data isn't of high quality, if we are feeding the model garbage, then garbage essentially comes out. So how do we know if it's any good? One of the solutions is clustering analysis. We can group data points with similar characteristics and visualize them in our vector space. We can reduce the dimensions to 2D and preserve the global and local structure. There's an algorithm called t-SNE, and this essentially produces something like this. And we can sort of say, okay, why is this point a bit separated? Why are sort of these blue points in another cluster where it shouldn't be? Or why are these points sort of messy? We could also use high dimensionality, so 3D, that could separate it out better. But this sort of makes it harder to work with. And how do I select these points? How do I see the other side? So our solution is, can we use virtual reality to essentially visualize this? What if we could transform the space with our hands? What if we could sort of resize it and manipulate it? We could augment points with point error metrics and precisely select specific points while in the visualization. Now Adam will do a demo of the final project.
This is our app. We've got the points, we've got the menu, and we've got the functionality to load points from an arbitrary endpoint. So I can pick up the box and I can move it around with my hands. I can look at the visualization from different angles and get a sense of the three-dimensional perspective. And then I can zoom in on a particular region. So let's say I'm interested in this region here. I can grab and zoom in, and then I can look all around. And what I'm trying to do is to find points of a color where they shouldn't belong, such as this point here. I can select it, and we can see this is supposed to be a 3, but the surrounding points are all 2s. And this is what the 2s look like, and this is what the 3 looks like. And you see how they kind of look similar. You could, well, as a human we know that of course one's a 2 and one's a 3, but the shape of the 2 is quite similar to the shape of the 3 there. And that's why these two are close to one another. And for another example, we could go over here and select these. And we see we have what looks like, well, what's classified as a 0, but there's so much squiggling going on there that it's really hard to tell whether that's what that's supposed to be. So you can see how it could be misinterpreted. So our app is mainly for being able to explore and find these regions where different points might look similar, as you can see. And we have additional menu functionality, so we can change the confidence here. And what this does is it will show those points that that shouldn't be where they are, like the red point next to all the yellow ones, which is a funky looking 8, or funky looking 7s that what are they supposed to be? Have a look. Funky looking 7s that look like a 3. Yeah, that looks like a 3, doesn't it? Yeah, we have a lasso selector as well. And what this will allow me to do is it will allow me to drag a region of space and select all the points within it.